This will be part 2 of 2. So it will go for 1 hour. So this is our second part. In first part, we have seen all the contents and we had a brief description of each and every contents. And now we will go in details. You can stop me anytime. I really appreciate you if you can stop me because I like to answer question. So don't hesitate to stop me at any point. So you, all of you here come to learn and don't hesitate. And unless you may not get thing. If you have question and keep silent, then you may not get the 100%. So do not hesitate to ask me question. Okay, so I'm going to start the detail one. So first one is computer hardware. This section will make you a little bored because many of you know many things here, but I'm considering all of you do not know anything about computer of this slide. So that's how I will progress. Okay, so take it easy. Computer hardware and software, two things. Hardware, you see, this is the computer, right? Desktop, if I consider it as a desktop, and this is the keyboard, and this is the mouse. So this is a typical desktop. But which one is actually computer? This one or this one? This one? This one is computer. Okay, good. Now it is 2022, right? In 1995, one snatcher snatch this one. He thought this is the computer. At the time, he didn't know that computer is the box one. He thought, oh, it is a box, look like a box. He he thought it is computer. So lack of knowledge. So if he perform this course, then he may he may choose the right one, right? Okay, kidding. So this is hardware, all about hardware. Hardware has the box. Motherboard, it resides into the box, yes. And this is monitor, this is keyboard, this is mouse. All of you know this. So let's bring this box in front of you. Yeah, this is the box. Okay, and let's lay down on your table and open the shutter of that box, and you will find here a big circuit board where you will find lots of copper cables, a very thin copper cables, like here, very thin copper cables. What does it box? What that box name? This is called motherboard. Yes. So motherboard is the box. This is motherboard. Or somebody said main board or motherboard. And you'll find one small circuit, I mean small black, its name is processor, but it look like so many cables are attached with it. What is that? It is, long before people called this box as CPU box, but this is called casing, actually casing. This box name is casing, and this is monitor, we know, but this box is called casing. Okay, so this will be this is called CPU, central processing unit. Central processing unit. And you'll find a 6-inch long two circuit which is attached into the motherboard. This is called RAM or memory. This is computer memory, and this is computer central processing unit, which process data. Suppose you send, hey computer, can you sum up 2 plus 3? Then CPU sum up. CPU, this device sum up. And you will find one device which is upper side of the motherboard, and which is connected with a big cable. What it is called? And it has a cylinder inside of this device. What it is called? Hard disk, HDD. CPU is equal to central processing unit, and RAM is random access memory. Yeah, I know many people know this. Okay, random access memory. But in summary, I mean, RAM is called memory, and HDD is hard disk drive. Why it is called hard disk? Is there any soft disk before? Yes, before they have soft disks. I mean, long before, when you see you see the gramophone, and big record is there, very soft, like hard paper. It is soft, so that one is called soft disk. But after that, the disc become a steel plate, magnetic plate, and it become hard disk. But now, which technology is now for? So this hard disk is for store permanently. Hard disk store permanently. Okay. Huh? Metallic hard disks to store file permanently. Suppose you write you write any file in Microsoft Word, and you see in the screen, this is my Word file, and this is my writing, something I write here, Word file, but you did not save it. All of a sudden, electricity gone, and your battery, then all of your data will go. Why? Because you did not save it in your hard disks, where files store permanently. When you write these things without saving, that where it store into the RAM. Inside RAM, some places. So RAM, if I store anything, any value into RAM, it is not permanent. It is RAM is temporary, to store temporary data. Store data temporary. Memory, RAM, always store data temporary. When I write the Microsoft Word file, and I can see all those writings on my screen, but once the computer power become gone, and shut down by accident, then all your writing will go out. Maybe auto save, maybe save your some part of the file, but most of the file unsaved part will delete from the computer, because it is not saved in hard disk drive that store files permanently.
Actually, when it is forget to save HDD hard drive, so it's not so permanent here, right? But there is that. It must be on the RAM it will be in between, yeah,
Um,
in the form of waves or
yes, I mean, yes, good question. He's asking that whenever I type A from the keyboard letter, keyboard button A, then where the A goes? For sure, it is not saved in,
save it.
yeah,
So where is it?
yeah. For sure, sure, it is not saved in a hard drive. So actually, where the A letters yeah, stay for temporarily, it stayed into the RAM for temporarily. Eh, Uh, so so from hard drive A goes to computer, and RAM process it, and display adapter shows back to into the screen monitor.
The temporarily is the some duration time.
I mean until you save the data into hard drive, that much time it will be it will stay into the RAM. So this is actually the computer, and suppose I do so let's do one thing. I mean 2 plus 3 is equal to what? I ask computer, hey computer, what about 2 plus 3? So I enter 2 by using my keyboard and enter 3 by using my keyboard. Also the operator also I enter by my keyboard, and then CPU process it, central processing unit process it, and it send the output to the display. And if I want to save 5, so if I put it into the file, then the file will save into the hard drive, so that in next day or next year or next month, you will see the file has 5. So these are the operations, basic operations of computer. And nowadays, hard disks, instead of cylindrical hard disks, long before it was cylindrical hard disks like this, it rotates in speed, but nowadays the hard disks become SSD, solid state drive, like your pen drive or USB drive, small pen drive, 20 GB, 10 GB. So this kind of technology hard disks use to save data, store data. So your hard disk configuration is 256 GB. That means your hard disk size is 256 gigabyte. GB means gigabyte. Byte means byte means the measurement unit of space. Suppose my RAM size is 8 GB. What does it mean? RAM size? RAM is, your laptop RAM is 8 GB. That means your laptop has 8 GB of space. Suppose you have many spaces. Suppose you have, yeah, lots of cubes, and suppose you have very big space. And how I can measure this space? Suppose this is your office space. If somebody want to rent this space, then you have to tell him how big or what is the measurement of that space. You can say it 500 square foot. So square foot is 500 SFT square foot. SFT is your measurement unit. Yeah, two-dimensional. So it is measurement unit. Um, in this way, when you buy any RAM or hard drive, they told you it is 256 gigabyte. That means it has 256, suppose byte. Every byte look like this. This one part. I mean, okay. Let me. Every byte look like this. 1 byte, 2 byte, 3 byte, 4 byte. So you have 256 gigabyte. So 1 byte space. How big is 1 byte space? Okay, giga. So 256 gigabyte. Okay, gigabyte.
Gigabyte is the space, right?
Space.
It has to be 3 dimensional.
No.
Third dimension.
No. In
Space.
space. Space means the space means cubical things you are thinking about. Then what I can see say the floor space. It is square foot floor space.
I put something later on. Say the gigabyte
Uh,
is space.
is the space of the hard drive, correct?
Space is always 3 dimensional. They save some bus.
Oh, okay,
If it
okay.
is in
Oh,
space,
okay, okay.
It's a 2 feet this way, 2 feet this way.
Cubic feet.
Multiply all three, that's the product.
Product of the like a refrigerator space.
That is cubic feet.
Cubic feet.
Square feet is for 2.
Yes,
wide,
correct.
1 feet
Correct.
wide.
Like the refrigerator space.
So my question is coming that everybody has like this thing 2 by 3 multiplied by 8 is something which is stored there.
Stored there. Yeah.
So if I am saving that space, so can other person come and save the same space?
Oh, no.
Yeah, that's what.
So yeah, I mean, if you save some part of the hard drive, then other person, if other person come and save their file into the same hard drive, then it will store into the empty space, not in other. Okay. Yeah. Thank you. And 256 gigabyte means you have 256 spot. I mean, this kind of square. So this is one square. This is one square. It is 1 byte. It is another byte. It is another byte. Another byte. In every byte, you can store only one character, like A or B or C or small a, small z, whatever character, or @, all are character. What is character? We'll see into the keyboard section. That means you can store 256 gigabyte character. Then how big it is? 256 gigabyte. So hard disk size is, okay, yeah. SSD versus HSD. You can go through these definitions, but only that much knowledge you need to know that SSD is solid state drive. SSD is solid state drive, and HDD is hard disk drive. It has cylinder. Let's see here, cylinder. Okay. And let's go back to here. So your hard drive space is 256 gigabyte. How big it is? If I say, actually byte is like inch. Suppose your house is 256 square inch, INCH inch. If I expect it express this way to any buyer, suppose I want to sell a house and I'm telling him, yeah, you will get 6 million square inch, then buyer will not understand that much. So I need to tell him that, oh, you will get 3000 feet, I mean square feet, square feet, square feet. Then he will understand. So same way, so byte, gigabyte is like 256, that much big, byte. So there is a relationship in between them. So let's draw this, let's do this relation, let's see what is the relationship. So 1024 byte is equal to 1 kilobyte. But before that, every letter A, I mean, you see in the motherboard all the copper cables, thousands of copper cables, like thin like hair. It is printed on the board, in the main board. So those copper cables, each copper cables is called a bit, 1 bit. All bit. This is called 1 bit. What is bit? Bit is nothing but a copper cable. This copper cable is very important for, I mean, in terms of the civilization of computer, I mean, human civilization. 200 years ago, Morse used this copper cable to send one big letters. Hey, mother, you'll come sharp. So letters. By using this copper cable, one copper cable, and and one postmaster sent it to another post office, it goes to several, and there is a relay station also. From this post office to this post office, maybe 5 mile distance, and then this post office, telegram. So Morse use this one single copper cable to exchange information. It may be personal letters, it may be official letters, whatever. So Morse use this information. Morse said to the other end, hey, if you see any bulb lit, you will make it as positive. I mean, in one copper cable, we can send electricity, or in one bit, there is a two state. Either it has electricity, or, I mean, it has positive or it has negative. Is there any other state it has? One single copper cable? Only it has two state. Either it has electricity or not. So this is the mechanism in current computer industry. I mean, how computer evolved. So scientists say that, okay, so from now on, let's to make it easier, let's rename it 1, and this one will be 0. So if there any electricity, then make it 1, write it 1, and if there is no electricity, then make it 0. So this is called 1 bit. Suppose I want to send some letters or information. How? I said in the other end, hey, if I send 1, then you will consider it as A. And if I send 0, then you will consider as B, right? And then, okay, I have got A and B. What about other 24 letters? Unless how you can send any expression? Then scientists said, okay, why don't we use another bit, 2 bit? So then they use 2 bit. In 2 bit, how many letters they can send? Suppose, let's do the combination. And first combination, it is 0, 0. When both bit are 0, then consider it as an A. Then first one is 0, second one is 1, then consider it is B. Then first one is 1 and second one is 0. I mean, they derive all the combinations, and they I mean, mark it as expression of letters, right? Like 1, 1 will be D, 1, 0 will be C. So like this way, they send successfully 4 letters. Then they got the clue, and then they increase the bit, number of bit. So they increase, and then they increase, and then they increase, and then finally they see, after many years of research, whenever they send 8-bit, then all the letters and numbers, punctuations, and all the letters, characters, whatever we see in our keyboard, everything can be sent. So 8-bit becomes standard. So I mean, Second World War. So they enhance the Morse revolutions, Morse invention, Alexander Morse, and they enhance by increasing the bits, so that they can send, I mean, 00004 and 00004. So this, I mean, by sending the 8-bit, they express it as A. Actually, A is not this, A is this, A. And then again, 1000 and 0001, they say, called it as B. You can combine 256 variations by using 8 bits. 256 way we can express the bits. So in 256 combination we can perform by using 8 bits. So this is called the ASCII, ASCII, and then finally they generate the code which has 256 pictures. Suppose this one is A pictures, this one is B picture, the next one is C, D, E, F, and all the things whatever you see in your keyboard, ASCII, you see here, A, B, C, D, E, F, all are ASCII code, and the binary number, the 01 number is this. These are the ASCII numbers. These are the ASCII numbers. You see here. So 0 is null, and A, where is A? 65. Where is 65? 65 is A. And 97 is B, small a. All the letters, all the numbers, 0, 1, 2, 6, 0, 1, 2, 3, 4, 5, 6, and all the punctuations, all the maths, all the special characters, the scientist can accommodate these for 8 bits. So this 0, 1 only understand by machine, and 8-bit become can make a letter. So 8-bit become a byte. So I can write it here. 8-bit is equal to 1 byte, and 1024 byte is 1 kilobyte. 1024 kilobyte is 1 megabyte. 1024 megabyte is 1, yes sir, gigabyte. 1024 gigabyte is equal to 1 terabyte. We are in many of us has 1 terabyte size laptop hard drive. So 1 terabyte we have already at home nowadays. Yeah, 1 terabyte. And 1024 terabyte is called 1 petabyte. It is still in to the big and giant companies nowadays in their office. And then zettabyte, yottabyte, we don't need this one. Maybe after a few years, maybe we don't need to know, but up to petabyte is more than enough to know about the computer hard drive size and RAM size. So your RAM size is 8 GB. Then how many bytes? Find the bytes. This is your homework. And we always express bit in this way. Bit is B and byte is capital B. Offer you 32 Mbps, megabit per second. Then how many character it will pass? I mean, what is the speed? 1 byte is 1 character. So per second, how many character you will get? 32 character? What it is called? It is bit or byte? Byte is character, but bit is not character. So this is character. This is 1 character. But this is not. This is 1/8 character. I mean 1/8 portion of a character. So Spectrum offering you 32 Mbps Mbps speed. That means how much you get it in byte? How much will be in Mbps? Mbps, capital B, megabit per second. 32. If it is 832 megabit per second, then how much it will be megabyte per second? 8 bit is equal to 1 byte. Then how I can calculate this? By dividing 8. So 32 divide 8, that means 4 Mbps. You actually getting 4 Mbps. Where is the bit I write? Here. Here, bit. So in one bit, we have only 2 state. Oh, why don't 1000, right? The 24. Why I use 24, right? 1024. Yes, I mean, so that is my answer actually. So one bit has 2 state, either positive or either 0 or 1, right? And 2 bit become how many state? 2 state. 2 state. I mean, yeah, 2 bit become 4 state. How I get it? Number of bit let me write it in small font. 16. 6. So number of bit to the power, how many state? 2 state of each bit. So if I apply 2 bit, then total how many character I can accommodate? 4. If I apply 3 bit, then how many 3 bit? 2 square, 2 cube, then it will become no 8. If I apply, okay, let me do this here. If I apply 2 to the power 4 bit, that means 4 bit, then we will get 16. So 4, 8. If I apply 1, I should write here 2, I mean 1 bit and square. Where is the square? This is the square. So 1 square, it will be how much? 2. Sorry. Oh, not 1 square. 2, 1. 2, 1. Sorry. Yeah, 2. And 2, 2. I mean, power is number of bit. And sorry, power is number of bit, and total state is 2. So this way, okay, let me do it here. So if I apply 1 bit, then 2 to the power 1, that means total 2 character I can express. If I apply 2 bit, then it will be 4. If I apply 3 bit, then it will become 8. If I apply 4 bit, then it will become 16. Then this way, 16, then 32, then 164, then 128, then 256, then 512, then 1024. So they will not get 1000. So that's why this is the calculation. Suppose if I have 1 bit, then I have 2 state, 0 or 1, right? If I have 1 bit, then 0 or 1. So 2 state. How many bit? 1. So this will be calculation is this will be number of bit, this will be the power, and the base will be 2, because every bit has only 2 picture, 0 and 1. Suppose in decimal value, if I have one digit, then how many variation I can express? I can write 0 picture. This is picture. If you consider it as a picture, 1 picture, 2 picture, 3 picture, 4 picture, how many? 10. For 1 decimal value, I can express 10 for 1. So it will be 10 to the power 1. For 2 decimal value, how many variations I can have? For 2, 0 to 99, how many? 100. 0 to 99. That means 100 variations, permutations I can have, right? How it come? For 2, it will become 10 times 10 to the power 2. This become 100. But this calculation, actually, it is for your understanding, but it is little bit, extra. But just memorize this. It will be much easier than this one. Because our time is short, unless I will express it a little bit more. And computer hardware is, we cover some things. Whatever is necessary. There is a lot many things. These things, ports and other things, we will cover in next slide. And this is processor, as I told before, and this is the calculations, and this is the RAM picture. And I just complete up to 1.2. In the next class, I will start from computer network, which is slide number 14.